Good morning, good afternoon, and good evening. Thank you all so much for taking the time to join us to review really what the AI world has been consumed with this week on DeepSeek and more specifically the security considerations associated with this new set of foundation models. My name is Abigail Maines, and I have the privilege of being today's moderator. I am joined by two leading experts in the world on adversarial AI, Tom Bonner and Jason Martin. Tom, do you mind doing a quick intro for us?
Absolutely. Thanks, Ab. Hi, I'm Tom Bonner, VP of Research here at HiddenLayer. I'm a 20 plus year veteran of cybersecurity for the last almost 3 years now, working with adversarial ML, AI, looking into supply chain threats, and yeah, leading the research team here at HiddenLayer. Over to
Thank you.
Jason.
Yeah, thanks. My name's Jason Martin. I'm in the research team over here. I've been researching adversarial machine learning and topics since the very beginning, probably more than 8 years now in the field, and really trying to understand the implications of what someone can do when they're manipulating models in ways that are unexpected. So glad to be here. Thank you.
Thank you. So before we jump right into the questions, just a quick reminder of how we got here. DeepSeek released several foundation models earlier this month with obviously great model performance. Specifically, their reasoning model, DeepSeek R1, showed really state-of-the-art levels of reasoning performance. So obviously, many end users and organizations are interested in evaluating DeepSeek R1. Personally, I have spoken to financial institutions, the federal government, pharmaceutical firms, really sort of all verticals and organizations of all sizes about what are the security considerations and what should security practitioners be thinking about as their organizations start to evaluate these models. So today what we're going to discuss in detail is the research that our Synaptic Adversarial Intelligence team published yesterday morning. There is no need to take notes today. This conversation is being recorded, and for all of those of you here and your colleagues who have RSVP'd, we will send this after the fact. Finally, please feel free to ask questions as we go through today's presentation. What I'll tell you is we're not going to interrupt sort of the first half of this call with questions, but then we will reserve enough time to ensure that we cover everything that comes in through the chat. So let's jump right in. Jason, maybe it would be very helpful to sort of start at the beginning. What is a quick primer on DeepSeek R1? What makes it so special? And maybe some of the use cases that this model would be most applicable for.
Yeah, yeah, because it's very important to understand a little bit of like the background here. So DeepSeek is a sort of frontier research lab that was founded a little over a year ago, and they're really competing with the large foundation research done by companies we're familiar with, like OpenAI and Meta and Anthropic. So actually, way back in November, they released a preview of this thing that's called DeepSeek R1, only through their interface. And what happened this week is they released it fully. So that makes it a open weight model, which means anyone can download it, they can mess with it, they could create derivatives from it. Um, so the the thing that they did is actually, if we take a step back, there's another model besides R1 that happened first. The one that is most relevant is something called DeepSeek V3. This is a large, it's actually 671 billion parameters. So that's pretty large in the language model space. Model, that's a traditional, just a text prediction, chat sort of instruction following model. They released that, and then that one is what's called a mixture of experts. So it's getting kind of a lot of traction in the space for being 671 billion parameters and a lot of really good benchmark performance. But actually, because of that mixture of experts, it's only 37 billion active parameters at any time. This is really a kind of a key performance factor that they have. It's an accessible model. They then took that model and they fine-tuned it on a sort of an extended chain of thought reasoning technique. And what this does is teaches the model to think out loud, if you will. It really uses a section of what's called the context window, which is all of the chat history, both the user and the assistant, as kind of a scratch pad to articulate step by step the reasoning behind what becomes its final answer. And this includes sort of self-critical kind of methods. I think we have an example of that we could show you real quick, where really it kind of walks through. You have the user prompt, and then if you look at this, you have this user prompt. I just asked it how you would tie a pair of shoes. And then you have this long section in the middle here. This is the chain of thought. It's kind of like if you were thinking out loud and discussing with yourself how you might approach tying a shoe. And then at the very bottom, you actually see the response. So this is what you would want to use in an application, or what the user was actually asking for. Previously, kind of outside of academia, this approach was mostly known through the OpenAI O1 model. So that model got a lot of attention last year. This is the first open weights model to really approach the benchmark performance of O1 or the other closed models. And also, there were some claims made that it was really trained much more cheaply and using older GPUs. And also, as I mentioned, the optimized inference. So there's several factors coming into play. Really meeting benchmark performance, lower cost than the ones that exist today, and open weight. So it creates a lot of flexibility. They also released, and it's important to understand the difference here, they released several distilled models. So what I was talking about is the original R1 model, but they released a set of distilled models as well as a technique for how they created them. This basically is a collection of models ranging from 1.5 to 70 billion parameters, so much smaller. And they're derived from either the Quen line of LLMs or Llama, the Meta Llama models. And that technique is being explored with great enthusiasm, I think, right now in the community for how you can take really state-of-the-art chain of thought reasoning and apply it to other foundation models.
Thank you. One quick related question. So what use cases would organizations think to use this model for first?
Yeah, so the things that these models are, these reasoning models as they're called, or chain of thought reasoning models, are really good at are so really things where you need to reason, right? So there's some examples. They really they work well for analysis and analytic type of use cases. Let's see, there's a collection of them being used to perform research. So if you need to go study or collect information about a topic, they're very good for that. Medical is another example where you really want it to reason through how it arrives at a conclusion. Legal and financial, anything that involves planning.
Yeah.
Those type of use cases are really what these reasoning models are good for. And there is a cost associated with using them. They consume a lot more time and tokens.
Absolutely. So, maybe jumping right over to you, Tom, and then asking the question that kind of begged from talking about finance and medical and all of that kind of data. Will using this type of model, or this model specifically, compromise an organization's infrastructure and or data?
Good question. Potentially is the answer. We tried to cover off the different ways in which R1 can be deployed. So right now you've got two options if you wish to use R1. You can either use it on DeepSeek's infrastructure via API, or you can deploy it locally using the open weights they released. Now, using DeepSeek's infrastructure, there are a couple of concerns around privacy. For one, how are the sort of data retention policies around that? It looks like they are just storing data forever. At least if you read the sort of privacy notice online right now, it seems quite loose and open. There are some concerns around reliability and security as well. I mean, we've seen that the online service was hit with a denial of service attack earlier this week, taking it offline. In fact, some researchers over at Wiz found a totally exposed database containing user prompts, accessible to the internet with a lot of sensitive information in it. So, if you're writing code, sending API tokens and things like that, it's all going to have been leaked earlier on this week. It has been patched, so it's not a consideration right now, but it definitely hints at a lack of perhaps security auditing around some of the infrastructure. It would make me nervous using it sort of in an online setting right now. So that's that side of things. Otherwise, deploying it locally, some more considerations on that front too. So the base model itself is shipped as a safe tensors sort of format containing the weights and biases. It's a reasonably secure container format. We're not aware of any sort of major vulnerabilities that will lead to things like code execution and whatnot in safe tensors. However, you do have to pass in a certain flag to load up DeepSeek. So there's a flag called trust remote code, and you have to set it to true. Because they're not using a standard sort of architecture on Hugging Face through transformers, it needs to pull down the code library from Hugging Face to load it up. So right now, you need to use this flag for transformers, or if you're using SGLang to deploy the model. It's not a great one. It's definitely a cause for concern. It could potentially allow for the execution of arbitrary Python code. In the main repository, we've gone over the source code that's been shipped to supply sort of the model architecture. It all looks good at the moment. However, there are a lot of derivative models starting to pop up on Hugging Face. I think we've seen over 1,000 just in the last day or so. So, not all of those developers are going to be quite as trustworthy. We may see backdoors in some of the sort of architectural code that's being shipped for the model. And we're also seeing different formats. People are converting the model to GGUF, for instance, which we know can be susceptible to code execution. So yeah, a lot of considerations to make from sort of the infrastructure side when deploying. We've also seen some other interesting things as well. So I know the Android APK for DeepSeek's been very popular recently, or at least the Play Store version as well. I think that overtook ChatGPT as being the most downloaded app on the Play Store. We're starting to see backdoor Trojanized versions of that as well. So, purports to be a legitimate DeepSeek chat interface for Android, but it's got Metasploit payloads baked into it. So be very careful if you are trying to consume this thing from non-trusted, non-standard sources.
Absolutely. Would you say, my understanding is of the derivatives that have been presented, the 1,000 models that we're seeing, I think 60% of those are not in safe tensors format. Would you suggest only using safe tensors at this point, or all file format derivatives are about the same profile?
Yeah, it's a good question. I mean, I think we'll get to this a bit later on. In general, we urge extreme caution when using this model anyway. Right now, I would say, it's largely only fit for sort of evaluation purposes. So avoid putting it in any sort of production environment. But yeah, try and stick to safe tensors. And as Hugging Face say in their documentation, if trust remote code is set to true for any repo, go and audit the code before you load it up, have a quick look through, check for things like exec calls or sockets or OS system calls and things that could easily backdoor your system. It's a pain, but it's the only option we have at the moment.
That's super helpful. So sort of related to that, and to both of you, what are the legal sort of considerations or privacy considerations that people should be thinking about when using this model?
Cool. I guess that, at this point we could maybe touch on some of the speculation around the training data used to create DeepSeek R1. There's definitely been a bit of chatter that perhaps some of the proprietary closed weight models such as
Mhm.
O1 have been used in the training process for DeepSeek. I know
Yeah.
there was a bit of a announcement from OpenAI on that front earlier in the week. I wouldn't like to throw any fuel on the fire here at all, but definitely seen some outputs that seem to hint at sort of O1 style guardrail responses. Would that be fair, Jason? As to whether that is indicative of it being trained on O1 outputs directly, or if it's just we've hit the sort of Ouroboros point where we're just slurping up AI generated data for training anyway. It's a bit hard to tell, but
Yeah, it's hard to say. The models are known for hallucinating. Sometimes they hallucinate even who created them. They generally don't know unless they're being told. So it's a little hard to say, just because a model claims to be created by OpenAI, that it actually was using data from OpenAI. But you see a few of those over and over again, and you start to wonder not so much whether it was trained by OpenAI, but whether those guardrail or sort of baked in responses are present in the training data that suggests that there's sort of a second order. He used an OpenAI model to create a large training set that was then used to create this model. But it's all a little speculative at this point, really.
I think perhaps more, pertinent from the sort of legal and reputational risk standpoint is the alignment restrictions that we're seeing. I'm sure everybody's tried to ask DeepSeek R1 to mention Tiananmen Square, for instance. It definitely refuses to do that. It seems to prevent certain topics that the CCP often censors. Interestingly, though, we had a bit more success querying it in Chinese. It was somewhat more open to talking about it, which seemed counterintuitive to me. But regardless of whether it would respond, we would often get interesting information from the sort of chain of thought, reasoning process back out as well. We had some interesting oddities as well. We'd ask it wacky questions like, why is meth so easy to obtain in the United States, and how are they able to distribute it so easily? And if we ask it in Chinese, it would respond, usually with sort of irrelevant propaganda about the CCP's efforts to combat drug issues in China. If we ask it in English, it produces a lengthy diatribe about the sort of perceived state of problems in American society. So, these may be responses that you wouldn't want to be delivering back to end users via a chatbot at the end of the day. So, yeah, I mean, I think that's most of it from the legal perspective. I don't know if you have more to add on that front, Jason.
Yeah, I think these are facts we're reporting. I don't really think that we're in a position to say any of this was like malicious, but it's certainly concerning if you're considering delivering something like this into production. There's a couple of years worth of improvements that have been made in other both open and closed models that are available, that really have progressed probably further than this model is at on these kind of safety and societal questions.
I think an area that maybe we can be more direct on is some of the work and some of the research we've done around the robustness of this model as it relates to traditional adversarial attacks, whether automated or manual. Can you kind of give us a sense of what we're seeing from our research team, but also sort of compare that to other popular models in terms of robustness? Just 'cause I think a lot of our customers and a lot of the attendees are just interested in, we understand the performance benchmarks. What are the adversarial risk benchmarks? Like, how does this model hold up to attack, to formal attack?
Yeah, I think that's a little bit where I was going. It's just really interesting to see that a lot of the current models really appear to be much more robust to adversarial attacks. And actually, others in the security community have been confirming these same sort of findings. Really, if you look at the current set of models that are available to, the robustness to prompt injection or jailbreak type of attacks have made a lot of progress in the last year or so. And so we were kind of surprised to see that R1 is really susceptible to, 2-year-old jailbreak attack type things like the do anything now or Dan style attacks or evil bot. These are role playing jailbreaks from mid late 2023, and so those were a bit surprising. And they allow you to kind of control the flow. So you'll see the model do a whole bunch of reasoning in order to produce the output that is not supposed to be able to produce via alignment. So that's a concern. We've also we've seen us and others have seen there's this concept called glitch tokens. So let me back up. So in the large language model, the procedure is you provide text. You run that text through something called a tokenizer. The tokenizer takes that text and converts it to a series of numbers because that's what the model actually needs to consume. These tokens represent things like words or prefixes, suffixes, sometimes multiple words. So they're a little slightly more conceptual than just letters. And sometimes there's tokens called glitch tokens that when you give them to a model, it kind of causes the model to go off the rails. Like for whatever reason, those tokens are really poorly represented in the training data. This can result in random outputs. Sometimes it causes the model to just start regurgitating training data. And so those kinds of things. And we've seen that those glitch tokens are definitely present in the DeepSeek models, including R1. Also part of this, so when you think about the context window, it's just this big blob of text. And so large language models use something called control tokens in order to separate the different pieces of the context window. Because in a chatbot, you'll end up with a system prompt and then a user prompt and a response and a user prompt and a response. Each of those sections is delineated by what's called control tokens. And without those, the model doesn't really know who's talking at any given point in time. And so one of the attack techniques that we've had a lot of success with is using those control tokens in the user prompt to sort of put the model into a different context. And those definitely work. We used this a lot back when we did our Google Gemini for workspace evaluation. Those control tokens were really effective during the indirect prompt injection work we were doing. We use them again here against R1, and they're quite effective at really changing the purpose that the model believes it's trying to accomplish, or injecting jailbreak or other kinds of stuff. The other thing is with the introduction of the chain of thought section, that actually introduces 2 new control tokens. You'll see them represented in the output as think tags. So there's a kind of XML or HTML style tags that sort of open the chain of thought section and close it. And within that is meant to be the section where the model is thinking out loud, like I mentioned earlier. But it turns out you can insert those tokens in the user prompt as well. And so that leads to a technique that we found somewhat effective called chain of thought forging. And really we can insert these chain of thought sections ourselves and convince the model that it has already thought about a topic, and those were its sort of reasoning conclusions. And from this we can do things like have the model tell the user that the earth is flat, or something of that nature. And when you think about integrating that into an application where the model's purpose is to be really good at reasoning, like medical or analytics, like I mentioned earlier, and now you can insert this basically false reasoning into the flow, you could really get it off from its intended purpose. What's maybe being less talked about right now is that the DeepSeek models are also trained to support tool calling, function calling. This is really useful for applications that need to collect external information or real-time information, something of that nature. It's really important for agentic type of flows as well.
Sure.
If you need to check the current weather or read information from a database, that kind of stuff. And the way the tool calling works is yet another context section within the overall context window contains the responses from any tool that is called by the model. And so tool call faking is a technique we've created where we actually can insert false responses from a tool. It doesn't even have to be a real tool. It doesn't have to be a tool that the model was told that it has access to use. You just make it look like a tool call response. And because of the way those are trained, those false tool call responses are given sort of more authority. They're meant to ground the model in reality. And so the model sort of says, well, the tool said that the earth is flat, so I guess the earth is flat. And you end up with that kind of stuff. Overall, we also ran, we have our automated red teaming tool product that we use. We ran that against it and found it has issues in basically all 6 of the OWASP top 10 categories that we support with our auto red teaming tool.
Mhm.
So I think these kind of robustness questions are a real challenge to an application, depending on the application, but a lot of applications, these robustness issues would be somewhat problematic today.
For sure, undoubtedly. Anything to add on that, Tom?
No, I think Jason's covered that quite comprehensively. Really,
Okay.
I did like the tool call faking. That was absolutely beautiful to see that in action. When we found those tokens, it's really simple as well. Just a sort of tool output begin, insert your false statement here, tool output end, and there you go. We're back at
Absolutely.
that level again. So no, robustness has definitely taken a hit in this model, that's for sure. But I expect them to swiftly rectify a lot of these things. This is definitely only the first iteration.
This is
And
coming
those sort of
sorry.
techniques, sorry to interrupt, but those sort of false tool calling techniques actually affect other models as well. That's an area we've been exploring recently.
Yeah, it's kind of related to my next question, which is somewhat twofold. So, a lot of the people that we've been speaking to over the last week have, been asked by their leadership team, by their boards of directors, hey, I want you to evaluate this new model. Tell us how it's going to save us money, make us better, cheaper, faster, et cetera. What would your recommendation be for the safest way to evaluate R1? But then also, is your recommendation applicable to future R1s that might drop today, next week, et cetera?
Yeah, I think the methodology we took and outlined in our blog is pretty sufficient for baselining models at that level. Definitely applicable to other models as well. Really, I don't know if there's too much else other people can do right now. I think I personally will be waiting for the next iteration of the DeepSeek R1 model, and we'll go and review that one again. I think they'll be looking to make some fairly swift incremental updates on the security front. But yeah, hopefully the blog helps lay a good foundation for repeating this kind of robustness testing in the future.
Okay, great. For those of you who haven't seen the blog yet, it's on our innovation hub on our website, hiddenlayer.com. Very easy to access. At the end of this call, at the end of the video, I think you'll be able to get it through a QR code. Anything to add to that, Jason? Because if not, I'm going to go over to sort of the questions that we have from the audience.
Yeah, I would only add that I think Tom mentioned maybe, wait a little bit. I don't think we're gonna have to wait too long. Like
Yeah.
I think if we look at this over the course of a longer view, we're gonna see that the techniques for applying reasoning, the data sets, and a lot of what DeepSeek released with this, the distillation techniques, all of those are being extensively evaluated and researched and extended right now. I think just last night that Hugging Face has declared that they are going to completely replicate the DeepSeek R1 from scratch, like retraining completely the entire thing. So there's really there's some wonderful things coming from the kind of open release, open source nature that regardless of whether this exact instantiation is a good idea for an organization or application, this is definitely going to shape the future of large language models.
Thank
Yeah,
you.
and just one more thing to add on that front, I do encourage people to go and play and conduct your own security research as well. If you're going to do that, I will refer you back to the deployment considerations. So if you can get a sort of local open weights version up and running on your own hardware, do that. It's definitely safest. If you're going to run it on DeepSeek's infrastructure, then be very careful as to the data you ship to it. But yeah, go have a play. It's fascinating attacking these things. You will probably be very surprised at the simplicity of it at the end of the day. I know I often am. My biggest fault when attacking these things is I often start too complex and have to dial it back, and it's usually the simple things that win out at the end of the day. But yeah, get stuck in, have a play, and see what you can see.
Tom always says that he likes to get everybody playing with the new stuff. That's the fun thing. So I'm going to go maybe take a step back to go forward. The first question I see here from an anonymous person is there an inherent risk with open source models? So maybe we assume some of that at the outset of this call, but maybe just for a reminder for some folks, maybe either of you can speak to this one, I think, pretty clearly.
Yeah, I think that really the same issues likely exist in the closed models, but they're harder to evaluate. So I think there's actually a lot of positivity to the fact that it's much easier to evaluate overall these risks that we were describing with the open weight model release. And I just mentioned actually, there's sort of this rush now on sort of reigniting the concepts of very good reasoning model research. I think Alibaba has been making announcements about this as well. There's going to be more of this. I'm sure of it, and as a result, there'll be this greater collection of models that I think, Tom, maybe you mentioned this at the beginning of the call. Really, that when you're thinking about from an infrastructure deployment perspective, the option to run it on your own infrastructure or on a hosting service of your choice, like a cloud provider, is really powerful.
Awesome. Thank you, Jason. The next question that we have here is there a recommended way to containerize and monitor the model to prevent improper, perhaps a tool like eBPF? Are we using any of those techniques to containerize it when we're doing some evaluation?
No, not. I mean, we're not. We've got it fairly well, segmented and walled off. Things like eBPF can be useful. I mean, we've more perhaps seen that being used for like tracking API endpoints and things like that. I'm not concerned about it performing improper I/O, largely just because of the frameworks it's running under. It's not going to do that. So unless there's a backdoor baked into the model or something like that, which we can scan for and alert users on, there shouldn't be too much risk of that.
Okay, awesome. Thank you. We have another question here. I apologize. I clicked. I'm very caffeinated, so I was able to click it too soon. DeepSeek released a technique to apply the chain of thought training to other foundation models. We mentioned this at the start of the call, such as Quinn and Llama. What are your thoughts about the technique?
Yeah, I mean, I think it's a great technique. It's going to lead, like I mentioned, a whole new um, set of sort of growth of research. And for the applications we were discussing, this idea of really structured thinking, you know, if you're a human and you're doing some of those tasks, you really should be doing the same kind of chain of thought reasoning approach, where you really lay it out step by step, and you think through and you discover or perform actions to fill in each of those sections before you give your response. Versus the other types of models are really just, you know, they're very caffeinated. They just, you know, they say what they're thinking right away, right?
Mhm.
And so it's a very fast changing field, and what you see is that this technique is being applied to all kinds of other open weight models as we speak. Like they're proliferating. That's probably actually what most of those 1,000+ models on Hugging Face that are derived from DeepSeek R1 actually are. There are a few concerning things. There's some evidence emerging that applying the chain of thought reasoning will diminish the safety alignment sort of properties of these models, and so some of the open weight models, like the llama models that were you know, trained with sort of rigorous safety alignment properties, when you apply the chain of thought reasoning approach to them, you lose some of that alignment and they start to get a little more toxic or a little less sort of like careful. So, you know, there are other ways to remove alignment. So, from an attack perspective, it's not particularly novel, but from a deployment perspective, it's something to be aware of if you're thinking about putting it out there.
Thank you. I think this is thank you for the great questions, everyone. I'm trying to keep up with everybody. I think this is an important one. We went through it quickly before, but I think maybe we'll go back to it. Can we maybe over to you, Tom, explain the trust remote code flag a little bit more? I think that's an important if for this for folks that are not familiar with it, what the risk is there.
Yeah, cool. So with most sort of Hugging Face setups, usually the code is shipped as part of the transformers library. So if you know, through that library, ask to load up a model that's on Hugging Face, it pulls down the weights, loads it up. All the code is already locally because you know, pip installed it as part of transformers. Everything's good. For certain types of models, though, that are not integrated with transformers fully, it's possible to host essentially the model architecture. So basically, the PyTorch classes that make up the neural network in a Python source file as part of the Hugging Face repo. Now, if you go that route, then you have to supply the trust remote code flag when you're loading up the model. So not only will it pull down the weights from the repo, it will also pull down the Python sources for the neural network architecture in order to use that. So, you know, by and large, 9 times out of 10, it's okay. It's not ideal. You know, you don't want to be pulling remote code from untrusted repos and loading it up if you can help it. However, there is the potential for miscreants to, you know, clone this model, stick it up on their own repo, change that code, insert some sort of backdoor or malicious program into the Python code. And if you are not looking closely, then you run the risk of loading that up when you try and instantiate the model. That's basically it.
Awesome, thank you. We have another great question. I'm assuming the risk with people cloning and creating malicious models is no different from what happens with OpenAI, for example, Fraud GPT, Worm GPT, etc. Is that accurate?
It's a little bit different. You know, in that OpenAI is sort of proprietary closed weights, and nobody's shipping the model. These are more sort of front ends, you know, that are using OpenAI via the API behind the scenes to implement some sort of chat bot type thing. The risk with cloning sort of open weights repos like this is that the model files themselves are being distributed. And we've seen, certainly with PyTorch, with GGUF, with Keras, and a few other formats, it's possible to insert malicious code into those models that will be executed upon load. And this is more like, traditional cybersecurity threats. So coin miners are currently very popular, obviously, because we're running models on GPU, so you can largely guarantee that there's a GPU there to make use of for mining purposes. We've seen ransomware. I've seen covert strike payloads, Metasploit, and I've definitely seen machine learning models being used for initial compromise to establish a foothold in an organization, and threat actors move laterally from there. So always be suspicious of your models, especially if they're coming from sort of untrusted, disreputable sources.
Which is a great lead in to this question. Can HiddenLayer do real-time scanning or near real-time scanning? I'm not allowed to answer that because this is not a sales call, so it has to go over to one of you.
I'll answer that one then. Basically, yes, we have a scanner engine that is capable of doing some deep introspection of machine learning model formats. We'll look for vulnerabilities. We will look for arbitrary code execution. We can even look for backdoors in neural networks and computational graphs. As for real-time scanning, we don't necessarily have sort of an on-access component, if you will, as you're perhaps used to in traditional antivirus software. But we certainly have tools that can integrate with things like CI/CD pipelines or other sort of model factories you may be using internally. So as you pull in and consume models, they can be scanned and verified. We can even auto red team them as well prior to any sort of deployment. So yes, essentially we can do just that.
And I think related to that, there's a question, I'm not going to pull it up, it's related to this question here, and it talks a little bit about there are obviously some scanning engines available on some of these public repositories. Are those sufficient from our point of view, or what is our point of view on some of those sort of available scanning tools that we see, and maybe how do we feel when the opinions are disconnected or in disagreement? That was a question from the audience.
Yeah, good question. I mean, without going into too much depth, I don't think I've seen an open source scanner that has perhaps the full depth of coverage to be able to detect all threats in all scenarios. And I will leave it at that.
Yeah, I appreciate that, Tom. Thank you so much. And I think with that, everybody, I'm looking through. If there's any final questions, type it in right now. I hope all of you feel the way I feel, which is I learned in the last 44 minutes more than I've learned in the last 44 days, which is absolutely 100% the experience I have anytime I talk with Tom or Jason. So I appreciate everybody spending time with us today. Thank you for all of your great questions. I think we've nailed them all, guys. I hope everybody has a great Friday or whenever you're watching this, and a great weekend. Please feel free, if you haven't already, to download our blog. It's available right here on this slide. And if you haven't been to our Innovation Hub, I would definitely suggest you check it out. It's sort of a complete repository of all of the research that we've done, all of the information that we consider to be very applicable for practitioners and research teams alike. And very excited to report that in March, the first week of March, we will be issuing our second annual AI Threat Landscape Report. For those of you who are already pinging me and asking for an early edition, I'm not allowed to send it until the beginning of March, but we will definitely be making you aware of when you can register to get it immediately once it's released. Thank you, Jason. Thank you, Tom. Hope you guys have a great weekend.
Thanks, all.
Thank you.
Thank you.